minute early, but we're going to do the more of 14.2 today, and then we're going to do the review tomorrow. And don't forget, Monday's a test. I will be here by 7 a.m., probably earlier. And I will stick around till I'm going to try to shoot for 9:30. But the official word is 9. That way I don't have to go and change stuff with access and ability and say, give them more and more time. Effectively 2 hours. The test shouldn't take 2 hours. We're going to do some, I got 3 problems. We're going to do regions on without doing intervals today. And then we're going to do some actual intervals on different ones. But the hardest part in this section is setting them up, not the actual integration. So I strongly recommend, if you can, graph them. So that's 1/3 x cubed. And that's y equals 3x. So we got some region like this. Looks like no matter which way we go, we're going to only have one line at a time. The question is here, though, what are the boundaries? So set them equal to each other. We know where the lines cross, the y value is the same. So we can set them equal to each other to find that value. So I have x cubed. I'm going to move the 3x over, make it minus 9x equals 0. The reason why I'm not dividing by x is because x can equal 0. And in fact, we can see that x equals 0 is one of the values, just graphically. So we get x equals 0 or plus or minus 3. The one that clearly matters here is the 3. So I've got 0, 0 as a point, and 3. If I stick in x equals 3 to this one right here, I get 9. So we've got 3, 9. So if we're going upward, we're doing dy first. So we've got f here. I didn't say what the function is because I didn't want you guys distracted by it. It's irrelevant at this point. The function we're starting with, we're doing y equals 1/3 x cubed. Up to 3x. Then we've got f here. And then we are going from 0 to 3 along x. And when we want to switch it around, we just need to rewrite these functions up here in terms of x. So y equals 1/3 x cubed becomes the cube root of 3y. And y equals 3x. X is 1/3 y. And we're going from the line to the cubic. So it'd be 1/3 y here, and then cube root of 3y here. And we got f of dx dy. And this limit, we are doing the y's, so 0 to 9. So that's the 2 ways we could set it up.
Usually it's like specifying it's
Oh, it's Jones.
Yeah.
How about interval from 0 to negative? Like negative 3x and negative 9 and for y to 0.
Down here?
Yeah.
I suppose that actually is captured by it, right?
Yeah, it should be the same as the other part.
That is technically part of it, isn't it? So in that case, we would have -3 and -9 is another point. You're right. That was me being lazy. So
I suppose we can just change the question, say this is the fourth quadrant.
Yeah, because usually in questions, they will specify that it's in like the
Yeah.
first quadrant. Okay.
yeah, I'm gonna also include x is greater than 0. Let's just do that. That'll make it easy. But actually, I think it's better off to discuss what happens if it's not greater than 0. Like if you're right, how does this change it? There's a learning thing here, because notice I can still do that either way, but what changes here is this one. I have this one that covers going upward, but going upward here, I'm going to go -3 to 0. So it'll be a plus this function down here. But now we are changing the line we're going from. We're going from 3x up to 1/3 x cubed. And this one, we're going from -9 to 0. And the cube root one is the one we're starting. Cube root of 3y over to 1/3 y f dx dy. So notice that the order of the limits change because which line is coming first is changing as we cross that x equals, as we cross the origin. So look, like, yeah, a lot of times they'll restrict it to x greater than 0 and y greater than 0. But if they didn't, you got to be aware, like, they changed. This is up here for that one, and this one's down here for that one. Same thing on the other one. You guys ready for another fun one? If you need this up longer, let me know. I'll bring it back. But otherwise, we're going to do the same thing. Our region is going to be 1 is less than or equal to x, less than or equal to e, and 0 is less than or equal to y, less than or equal to ln of x. And set up our function will still be f. I don't want to, we're not doing any integration right now. The hardest part I want to get through is, trying out different regions, get you guys more comfortable with that. Because if you're going to fuck up this problem, that's where you're going to fuck it up most likely.
Set up already.
Make sure you drop picture.
Pictures are very important. Like it always says, it's all about the pictures,
So it all just depends on which way we decide to go first. If we go upwards first, it's kind of set up. We're going from y is already given to us in terms of x, 0 to ln of x. Then we have 1 to e. Question is, how does this change if we go to dx dy?
That's all I get E is 1.
That is an e, yes. And that's an e over here. Well, two things we need to do. We need to convert this to be a function of e or x. So y equals natural log of x becomes e to the y equals x. So we have 1 is less than or equal to x, less than or equal to e to the y. And the question is, what are our boundaries on y now? Well, y equals 0 was one of them. That doesn't change. What's the y value here at x equals e? Y equals natural log of e. If you put that up there, you suck, because natural log of e is 1 and you should be using that. Fun? Ready for another? That one's not so bad. Let's bake your noodle on the next one. Oh, what is Jones going to do here?
This line. That higher than this. So, this is pretty much this. Why the- Yeah, he's right different. He's right.
Sorry,
I saw that he had lower. Oh, so it's whoever closer to 0, we're gonna go use it as a lower boundary.
Shit, we got to do this graphically. Who remembers the graph of sine inverse?
Oh, it's like unsee bungee.
So the graph of sine inverse looks a little something like this.
Haven't done for luck, but
And so Jones,
It's
could you go back to
restricted.
the last- could you go back to the last question real quick? You think there might have been a mistake?
oh,
From 1 to. Oh, yeah, so for your second integral, we think it might have been from e to the y to e.
come on, stop playing.
Wait, what?
You froze it again?
No, he's gonna, for the second integral.
You're right.
Yeah,
You're right. Good catch. Testing you.
Joe Jones.
That's an excellent catch. Yes, that's the correct.
make sure you're starting from the curves, not the.
The only thing I got right, I got wrong.
That's my bad, because we're starting at this line and we're going to that line. So that line is the x equals e to the y line. And this is the x equals e line. So I fucked that up. My bad. I got hasty. Trying to get to the fun shit.
Lower the difficulty on this test.
Yeah.
Fucking wrong.
Don't count on
So this is sine inverse. It's restricted to negative pi over 2 to pi over 2. And then we got boundaries on y. Y is 0 to 1. And y equals 1. And we have a restriction on x. Upper limit is pi over 2. So we're looking at this region.
He doesn't have me wrong.
We can either go up first or we can go right first. The way it's set up with x listed as a function of y, it might be more natural to start with that version. Going from sine inverse y up to pi over 2. We've got f of d and then dx dy and 0 to 1.
No,
How does this change when we switch over to the other way? Well, another way of doing this line segment would be to switch the line around, and that's y equals sine x.
So that graph is not looking accurate.
What's wrong with it?
It's concave.
Do you have the curvature wrong?
Yeah. I don't know if it really matters, does it?
It doesn't matter.
Oh wait.
Are you sure?
Oh wait.
let's find out.
Never
Here
mind.
we're going from 0 to sine x. And along x, we're going from 0 to pi over 2. Well, now you got me wondering. Desmos, where are you, Desmos?
That actually looks right, thinking about it, because you do y equals sine x.
Lawrence is
Okay.
gonna get a lower grade if I'm right, and he's got me second guessing. I had it right. It's not stretched out enough, but it's still right.
It's just not drawn to scale.
Yeah, it's just not drawn to scale. It had the right curvature. All right, now we're gonna hit up some ones that have some actual integration.
Oh, sure, buddy. Hold on. Hey.
Hold on. Okay, I'll hold on.
He's holding on tight.
All right, you guys ready?
No.
What do you mean no? No isn't an option.
You were too busy trying to call him out that you didn't neglect it to write notes.
Do you need to back up, Lawrence? All right, so Does anyone know how to integrate cosine x squared? Benjamin, don't give me some fucked up formula. Does anyone know how to integrate cosine x squared?
Oh, you could use series.
We could, we're not going to.
You-
The idea here is the integrating dx first is kind of hard. This might be easier if we can switch to dy dx. So how will it become easier, or will it? It's worth checking. So map out your region. X equals y over 2 is the same thing as y equals 2x. So y equals 2x. And we're going up to 1, so that's right here. And then we're going from 0, y equals 0, up to 2. So it looks like this region right here, this triangle. So if I wanted to switch the integral and go that way first, we have cosine x squared. That hasn't changed. But we're doing y first, and y is going from 0 to 2x. And then x is going from 0 to 1. And now all of a sudden, this might be doable. In short order, actually, since cosine x squared is not a function of y, this integral is just 0 to 1 of y evaluated from 0 to 2x cosine of x squared dy dx. So this pin is dead. Throw it away. Grab another fine tip one. I like this fine tip one, but this is my last one. Look at how nice that is. So tiny.
This works as a good news out.
It's too tiny. We got 0 to 1, 2x cosine x squared.
Oh, yeah, no, this is probably just a coincidence.
I mean, for, when we see the interval. Like, if they're an easier one, like, sine 2x, 5x, something like that. Got a rule like that. We would have to use something.
So conveniently,
You have to show them.
I don't need to change my limits of integration switching to u.
Typically.
It will stay 0 to 1, but now this is just cosine of u.
Awesome. Not the deal.
The smaller you said, I wouldn't worry about it. I'll take the sure for some time. So, Mr. Jones, Eric was wondering to what point that you want to see them do U subs.
Like the easier one, you will do it.
What do you mean?
Like cosine 3x. I need to use up the 3.
You don't need to do it at 3x one. I would recommend doing it here because there's an x on the outside and you want to show that the x is going away.
Gotcha.
But something where it's just a simple coefficient, I would. So we got sine of 1 minus sine of 0 is just sine of 1. How's that for fun? You guys ready for more?
Okay.
Find the area between y equals sine x and y equals cosine x from 0 is less than or equal to x, less than or equal to pi over 4. This is a good old Calc 1 problem.
Yeah.
Let me make it smaller. I'll do this. I guess the curve would look a little bit better like that. So this region, we want that area. Now it's not terrible to do in regular
Yeah, it's terrible. Trust me.
integration. I mean, we could do a regular integral from 0 to pi over 4. We need the upper line, which is cosine x, minus the lower line, which is sine x. We could do that. Is that where they cross? That's not where they cross, is it? Yeah, that's where they cross. Or we could look at it like this. We're not going to do that. We're going to use Calc 2 method, Calc 3 methods. Let's treat this as a three-dimensional figure. This is my x, this is my y. So I have a like that and a like that, and we're doing this region right here. And we could treat it as a volume rather than area, but we don't want volume, we want area. So if we give it a height of 1, z equals 1, which is our height, volume is area times height, but height equals 1, so volume equals area. And so we could do this as a two-dimensional figure. I would say we're going, let's do dy dx first, or dy first. So dy would be going from sine x is the lower one up to cosine x. And then x is going from 0 to pi over 4. And the where z comes in is that's the function we're integrating, just 1. So you probably wouldn't do this on this problem, but there are areas where it is just absolutely tedious. Like if you look at the video on this one that I did, the problem's shitty. You will note that when we do it, we get the same thing. We integrate this, we've got 0 to pi over 4 y from cosine x to sine x dx. That's a 4, not a y. And we're back to the integral we would have had in just doing the regular integral. This was the one-dimensional version, or the two-dimensional version. But the point of this thing was to notice that if this region is shitty, you know, you've got,
Shitty. Right?
If you got something that's like that and that, we can always do it as a height and make it a little bit easier.
That's great.
It's a flamethrower.
So if you finish this problem out, you've got sine x minus sine x plus cosine x. Evaluate from pi over 4 to 0. We got root 2 over 2 plus 1 minus, I'm sorry, root 2 over 2 plus root 2 over 2 minus 0 plus 1. So root 2 plus 1 or 1 plus root 2 looks a little bit better. I thought this problem would be a little bit more fun. I guess I should have worked it out first.
Oh, we got a question in the back.
Isn't that root 2 minus 1? Yeah, mine.
What's the question?
They were asking if it's root 2 minus 1 instead.
Like that?
Jones, basic algebra.
No, I didn't do very well in that class. It's a miracle they let me teach that shit.
Making other kind of mistakes next time.
It's so easy to make negative sign mistakes. Pay attention to that shit on test. Don't be like Jones. Don't go too fast. Be better than me.
Keeps filling me up
Don't
with,
fucking say it, Ben. I know you're thinking it.
What would I say?
I don't make mistakes like that, Jones. I am better than you. I hear you thinking it. I'm gonna be checking Ben's shit for dots on his eyes.
Oh, I see.
All right, let's do another one. Good catch on that, Eric. Oh, let's make you guys do a lot of work. All right, I'm gonna give you the luxury to choose
Good job,
what.
Eric.
This is what we're integrating.
I saw
Your boundaries.
Oh, maybe.
Maybe you did. I heard Eric.
God damn, you guys doing?
Those are your boundaries. Pick your path. Pick your poison. What? I don't have it to go so goddamn large.
Hey, can you put a fourth quadrant, please?
31.
What?
Can you put a fourth quadrant, please?
31.
I still didn't hear it.
Huh? You don't need to. Just say that it's in the first quadrant. Right? I don't think so. Yeah, it's gonna be in. It's gonna end up. Oh, yeah. You're gonna have the same problem you did earlier, where you're gonna have two different enclosed figures in two different quadrants.
Is it
Do
a
you wanna
problem or do we have 15 minutes left in class?
I mean, in the end, it's the same area. It's just multiplied by 2, right? In this situation, you could do that, right?
I don't know. Let's look at it. That's an excellent question. What does this graph look like?
There's no graph.
This is y equals 1 over x. So 1 over x is like that and like that. So that's our xy equals 1 line. And if I do y equals x, and then y equals 2x. So you're looking at these regions, aren't you? I think it's already complicated enough that we will add in the restriction that x is greater than 0. We'll add that in. I'll be merciful.
I'll be.
I mean, you could show that this is that. Or offsets that, but I don't want to do that because I don't want you to go, well, then the area is just 0. So we're just going to restrict that to being x is greater than 0. No, the areas wouldn't offset because we're doing volume, not area. This becomes a real challenge on what the boundaries are, aren't they? The limits.
Yeah, it's up to you. How you make that question though?
We can see where the highest point is right here, where y equals 2x intersects y equals 1 over x. So we'll just set them equal to each other. Where they intersect, they should equal each other. So we get x squared equals 1/2. What? X equals root 2 over 2. That's some bullshit. Which means y equals root. When we plug in root 2 over 2, we get 2 for the second point. So that's that point right there. We know this one, that's the origin. This one right here, we got to do the same thing. Y equals x hits the 1 over x line. But this one's a little easier. We get x squared equals 1. So x equals 1. And since y equals x, that's the 0.11. And it looks like no matter which way you integrate this, you're going to have to do 2 integrals, right?
Yeah.
if we go this direction first, we have, I'll draw a little dotted line to show the boundary. You got one order of integration there, and it changes when we get that. And if you go upwards, the left half is different than the right half.
So either way, you have to do 2 sets double integrals. If only you guys knew how to do the Jacobi one.
Do what?
I'll do that later, don't worry about it.
I don't know about you guys, but I'm inclined, I don't know if it's a bad idea, but since the function's x squared, I think I want to do dx first.
You want to do DX first? Okay.
Just because the function that we're integrating is x squared. I don't know if that's going to be a good decision or not. You guys might do differently, but if I'm doing dx, I am going, let's see, I'm going from left to right. So my first limit is y equals x. I'm sorry, y equals 2x to y equals x. Nope, I'm doing dx. What am I doing? Going upwards. So x equals y to x equals 1/2 y.
Make it Y, you go Y.
And that's from 0 to √2/2. And then I'm going to add, this one would be √2/2 to 1. And we're going from y equals x up to y equals 1/x.
Look at it. Oh, Y. I don't know what I'm doing. It's equal to Y.
Nope, got this backwards. Y and 1/y.
So by Y, you give is equal to 2.
So I got two integrals.
I know. Is equal to 2.
Gravity equals Y.
That's what you put on things.
So what does this turn into?
I think it's an answer.
I got a 1/3. I'm going to put that up front. If we cube that, we've got 1/8 y cubed minus y cubed dy. So that would be -7/8.
Oh, yeah, you have to cut it out.
With the 1/3 is -7/24. -7/24 y cubed that we're integrating. So if we integrate it, this looks shitty. This is -7/96 y to the 4th. Evaluated from 0 to √2/2. That's for the first half. That's not too bad. When we square that, we get 4 on top, 16 on bottom. This is just -7/96 times 1/4.
Oh, so you can see the between the right and the
Yeah, you did do that.
All right, so this one gets crappy.
That dy bound should be
I think it
0 to 1, 3 over 2, and 1 to square root 2.
was there root two.
We've got 1/3. I've got 1 over y cubed minus y cubed dy, and the integral is root 2 over 2 to 1.
Yeah, I'm doing y
So this is y to the -3. We go up a power would be y to the -2.
here.
We got -1 over 6y squared
So if you do y first,
minus
you should
up power is 4 minus 1/12 y to the 4th. Evaluated from root 2 over 2 to 1.
but he's using some.
Wait, what over square root two is?
So we've got -1/6. I'll do this part orange so it stands out a little bit better. We've got -1/6 minus 1/12
Less than 1.
minus
Square root 2 over 2 though. Yes, square root 2 over 2 on y bound. Y from here to here. Right? Square
if
root
I put
two
that
over
on top.
This x and
is y. Is x
Oh,
on
did it
the
do
function.
So this is 1 over or -1/6
Oh, you change that. Oh, I see what you're saying. You change that. You can go in.
2 over 4. So let's do some cleaning up here.
Is that even-
This quadrant right here is 3.
Of all the part, it's not in. Consider it someone. Anybody pop in?
And this is 148.
How he set it up. Okay.
Yeah.
My x is
Oh, but
All right.
you-
same as mine.
but you're doing
X
first.
So I was trying to cut it up. I was trying to cut it up. And like, you got 2 intervals. I was getting like 4 intervals. That's the only way I can think of even doing it.
That's good.
So 5 over 48 plus this value up here.
Yeah, you have a question?
I have no idea how he set that up.
Yeah, actually, Mr. Jones, I had a question about your setup for your dy. When you did the set the bounds for dy, could you go back to the graph? Looking at the graph, the first bound should be from 0 to 1 and then 1 to root 2 over 2, right? But you have 0 to root 2 over 2 and then root 2 over 2 to 1.
From
You're
1
right.
to
I
root
kind of
2.
fucked that up, didn't I?
Looks like he cut it up.
Serves off 15 minutes.
He cut it up into 4 parts. There's only 2 intervals.
And that's for your question. Let me come over there. So you have.
I have nothing. I have the answer. I have the question in the graph. That's it.
Okay, so you're not tracking for the graph. So what he essentially did is that no matter what way you want, whether you start by going y, dy, or start by going dx, you're gonna have to set it up. Do you understand that?
Yeah. And there's that. There's this over this, and this over this.
Yeah, for me, definitely more.
Or you do it the other way. Actually, what the other way you can go.
That's where it will go and start. You have to be done.
Okay, actually here. And it'd be this over this.
Yeah. I think we should say you.
How they?
This one should be 0 to 1 on the first one.
I think.
That should be 0 to 1, and this should be
Whole way where
1
you do like.
2/2. I got my. I got my- look at that. Come on.
You get the interval. This one's turning downwards. That's not how it is, like,
Yeah, and we're like it's a
Well, that changes the whole goddamn thing. You guys were supposed to tell me that 15 minutes ago.
Half of us aren't even following what the hell's going on.
That's because I've been wrong for the last 15 fucking minutes.
I set up differently.
But then, but essentially what he's doing, he's just splitting up into 4 parts. So, splitting up, that's what I'm
I'm wondering what that was.
If you set up the other way, what would you get if you set up the, this should be right. Is that looking better now?
Basically, it's splitting into 4 parts and then integrating it onto those 4 parts. So
The second one should be square root 2, not over 2.
That'd be the intersection here.
Well, actually, if you're going from y equals 2
Why do you,
are we doing it in y or x?
you're right, it's going along Y. Y is 2. You're right.
That's in terms of.
Oh, that's a hell of a lot easier. Look at me, I just done fucked up all the boundaries, every which way, every single boundary I put was wrong for X. That's fucking phenomenal. That helps, that would explain why no one's following me. I've been wrong and no one said a goddamn thing for fucking 10 minutes. That should be better.
Could you scroll up a little bit and I'll take a picture and put it on the Discord so if people want to try the problem themselves.
So the top of the problem is that.
Yeah.
From here to here.
I got it.
Okay.
Well, if people want to try it, because this is basically to the point where, like the hardest one of it's basically the hardest. Yeah.
You know, this is about as hard as it gets for this section. I strongly recommend putting this one out.
Is it off?
Yes.
I think I showed it's the hardest one in this section, right? Just done fucking brain wreck that shit.
But mine is off too, so it's
You get X, Y. Y.
Oh, you're not sure where you got root 2/2.
I'm just trying to figure out how to do this. I need to go back. I need to go back and watch all the videos.
Well, no, I understand why you're confused. It doesn't, because doing this is just, in the end, it's just splitting up into 4 pieces and then doing them separately, and it's kind of confusing sometimes.
It is confusing. I got confused myself. It's don't trip out about it. It takes time to get it right. That's a.
For
Okay.
upper bound, it's not 2. I think it's square root 2.
I'm looking at it and I just want to do.
You're right. Son of a bitch.
I just want to do the.
Still fucked it up.
Because apart from this, that makes sense. But then like, I'm trying to understand this. I'm trying to understand how he's like breaking it down.
In the end, this is the basis for how you do it in Calc 2, or why it works in a way, or like what? I'd say this is the expanded version of the Calc 2 version of finding the area of an enclosed space on a graph. Pretty much. Yeah, it is pretty much. It literally is the same thing. You're just using different notation. But essentially,
Well, we're not doing the area of this. This is a volume.
Yeah, volume.
this is a volume problem since you have a x squared in the integral.
Right.
But it's fine. It's the same idea.
That's what I'm not understanding.
Why it's a volume problem?
Well, I put mine. I set up dy dx. It's different than yours, so I hope my answer on this.
Well, dy dx, yeah, as long as you set it up right, we should get the same answer. I'll work this out a little bit and I'll put my answer up
Okay.
on Discord.
Oh, yeah.
Mine is 3 over
So you had to
16.
Change it a bit.
See you later.